Good afternoon, everyone. Welcome to this ASA ABLOY virtual training session, Manufacturer's Role in Reducing Embodied Carbon with Amy Musante. This session should last about 45 minutes. We will allow time at the end for question and answer. During the session, your lines will be muted. However, you can use the Q&A icon to submit questions as we go along. The session is being recorded and should be available to view through the Academy within 24 hours. Also, within 24 hours, you will receive an email showing your proof of attending that can be submitted to your employer or to some of our industry partners for continuing education credits in lieu of issuing actual certificates of completion for these short trainings. In addition, ASA ABLOY has over 50 online courses that are available to you at no cost. To get started, simply create an ASA ABLOY Academy account and begin learning at your pace. Let's turn things over to Amy. Welcome, Amy.
Great. Thank you very much, Tom. It's nice to be here with everyone. Those of you that are in our live audience and those of you that are viewing in this session at your own time, as Tom had mentioned, which is the great thing about ASA ABLOY Academy. So hi, I'm Amy Musante. I'm the Director of Sustainability for ASA ABLOY. I have been with ASA ABLOY for about 14 and a half years. I started in 2007 in a position with customer service with a little company that some of you from this industry may be familiar with called ASA High Security Lock. I am based in our New Haven, Connecticut headquarters office during normal times, but I am responsible for covering the entire United States. And so I, in a regular world, am out on the road collaborating with our door security solutions specification team, our sales team, and all of our customers as well. So today we are going to talk about embodied carbon, which is a topic that is becoming more and more discussed in the building materials industry. We're going to gain a very clear understanding about how embodied carbon exists in products and how companies like ASA ABLOY and others are utilizing this information to design more optimized products for the built environment. Today, we're going to learn about embodied carbon and how it relates to various LEED credits. And LEED is Leadership in Energy and Environmental Design. It's the world's most common green building certification program. We'll also review embodied carbon and how associated environmental impacts of building materials are involved. We'll discover available tools that you can use to evaluate embodied carbon in products. You can highlight where to find global warming potential information. This is information that you can use, that you can share with your teams, and take a look at how to assess overall embodied carbon in a building. And then we'll also talk about how manufacturers can optimize products utilizing embodied carbon information and communicate this optimization to the architectural and design community. The first thing we're going to dive into today are the market drivers and just why embodied carbon is such an important topic in the world of green building. We all know that LEED is a very important green building certification program. It's the most common and the largest as far as footprint is concerned in the United States and in the world. There are over 100,000 commercial projects that are tied to LEED, which is incredible if you think about it. Over 20 billion square feet of building space tied to LEED. 2.6 million square feet of space is certified to the LEED standard every single day. And there are over 204,000 LEED accredited professionals that are utilizing the various rating systems within the program. So some of you on this session today probably have a LEED credential like a LEED AP or a LEED Green Associate. So this information will be even more helpful for you. But our discussion today is focusing on embodied carbon. And so it's important to note that the U.S. Green Building Council, or as we refer to it in a lot of cases, the USGBC, has a larger priority area that focuses on reducing carbon for products and materials within LEED. And this is something that we're starting to see much more prevalent in the newer versions of LEED. So as you'll see on this slide, there's really three kind of major buckets or themes within the newer versions of LEED. So environmental product declarations, or what we call EPDs, and optimized low carbon materials products are ways that LEED is addressing this priority of a lower carbon building community. So during today's session, though, we're going to talk about the importance of life cycle thinking, analysis, and disclosure in order to really understand about how products are being used in a building. Another priority area within LEED is encouraging manufacturers to think more circular. So we hear terms like circular economy or thinking about the product's end of life. Circular thinking is a way to address embodied carbon within products. So we typically think about recycling or utilizing recycled content within products and developing extended producer responsibility programs, which is just a long way of saying a product end of life recycling program. So that's important with LEED as well. Additionally, another way to reduce embodied carbon in a product is by integrating bio-based and sustainably harvested materials. So that's not something that we're going to focus on today. That's something that is incredibly advanced, and there are manufacturers working on that. Incorporating bio-based or sustainably harvested materials can help lower the embodied carbon in a product, but it's not always guaranteed. We'll talk about LEED v4 and 4.1 for just a moment, because this data is absolutely incredible and encouraging at the same time. So understanding that interest in green building has continued to grow over time, we ran a quick analysis just to see what LEED registered and certified products look like from June of 2020 to June of 2021. And what's interesting to see here is that during the heart of the pandemic, or the heat of the pandemic, when there was a lot of uncertainty and interesting things of ups and downs within the industry, that's when registered projects for LEED v4 went from around 9,000 all the way up to around 15,000. And if you look at LEED v4.1, the registered projects between June of 2020 and June of 2021 shows that we went from 620 buildings to almost 4,000 buildings. So we're looking at roughly 9,000 new registrations in a year for LEED projects, which is incredible, especially given the ongoing situation of the world we live in right now. Something else that's interesting about LEED project teams is that we're seeing a lot more utilization of substitution for credits in v4.1 versus v4. And optimization of products as well as EPDs are two of those key credit substitutions, and we're going to talk about that in some detail. So the intention of this course is to talk about embodied carbon, and those that are familiar with this topic tend to be a little bit more advanced as far as LEED is concerned. So we are going to get into some detail in the next couple of slides. It's a lot to take in, so stick with me here, okay? We're going to dive a little deeper into LEED. And these are not your typical LEED v2009 contributions of what we're used to seeing for those past years with 2009. So we're continuing our discussion about driving a more sustainable product. And this is what LEED v4.1 requires in terms of the MR credits. So those of you that are familiar with LEED, you know that MR stands for materials and resources, which is basically a major foundation of where LEED is heading. This takes a look at building disclosure and optimization for EPDs. So for option 1, if you select 20 different permanently installed products sourced from at least 5 different manufacturers, you earn 1 point within the LEED standard. This is the credit that we're all very used to at this point. And this is beneficial because it's encouraging manufacturers like ASSA ABLOY and any other manufacturer within any number of CSI division to create environmental product declarations so that architects, designers, and building owners can start to really understand the impacts of products. So additionally, new LEED credit options like a multi-attribute optimization, which is that second area that you see on the screen there. For option 2, you're going to use slightly less product, so 10 different permanently installed products sourced from at least 3 different manufacturers. That gives the project team 1 additional point within LEED. So you can earn this credit by specifying products that have developed a life cycle impact action plan, which will qualify for 50% by cost or half of a product. So those percentages and the cost, that's what we're familiar with hearing with previous versions of LEED. So again, this is going to sound partially familiar to you. Or what you can do is select products that have completed a comparative analysis. And in that case, they're using a life cycle assessment or an environmental product declaration. So if you select a product that has a reduction in global warming potential, or GWP, that's the term we also use for embodied carbon, that qualifies as 1 product. Hopefully you're all sticking with me so far. If there's a comparative analysis done for an optimization that shows at least 10% reduction in the global warming potential, then that product will count as 1.5 products, or 150% by cost. So you see the correlation here is the more advanced the manufacturer can be with their analysis and with their product, the larger contribution it gets for the project team within LEED. So if a manufacturer has optimized their product and it results in more than a 20% reduction in the global warming potential category, then that's qualified as 2 whole products. And then in addition, you also have to show at least a 5% reduction in other LCA impact categories. And we'll talk about those a little bit further down the line. Now, for those of you that have not spent a ton of time in LEED, maybe you're a manufacturer or an architect, you're a designer or a building owner, an end user, you're looking at something like this and saying, this is incredibly difficult. Why on earth would we need to do all of this work? LEED is just trying to make our lives difficult. The intention behind these types of credits and these categories is to push the industry in a positive direction collectively, to challenge manufacturers to look much deeper into their entire value chain and to work collaboratively with architects and designers to say, how do we incorporate a better product into the building? And so that's what the intention is behind all of this. It is difficult, but it's, it's good to be up for the challenge. This is really driving the industry forward. So another pilot credit for LEED v4.1 is called Pilot Credit 132. And this credit is set up to encourage the procurement of low carbon construction materials. So again, this overall topic for today is taking a look at reduction of carbon. So step 1 is to calculate the building and its embodied carbon intensity baseline. And so you'll use materials published by the University of Washington, the Carbon Leadership Forum, or some other approved data provider, but those would be the most common. Step 2 is to verify those reductions. So in many cases, especially in the world of sustainability, we understand that there's some greenwashing out there. So it's always really important to verify the data that we have around sustainability claims. So what you're looking for here is an understanding of the impacts of the products that you've selected. An example of this might be, so if you pick a door, for example, and it has a global warming potential impact of 120 kilograms of CO2 equivalent per door. You could actually use that as a reduction to earn this credit. If you're looking at, if you wind up choosing a door that is, say, 110 kilograms of CO2. So you can maybe just make a very small change to the type of product that you're going to specify, and it actually will contribute to this pilot credit. Now, one more pilot credit as food for thought for V4.1. It's not directly related to embodied carbon word for word, but it does have a connection in terms of the fact that the intent of circular products pilot credit is to, of course, reward teams for selecting products that support a circular economy or a closed loop design. And so one thing that we know is embodied carbon in products can be reduced by integrating recycled materials. And so this would benefit companies that do incorporate materials that come from post-consumer sources within their products. So you can achieve this credit if you select, and here are the numbers that sound familiar again, 5 different permanently installed products from 3 different manufacturers that have already demonstrated achievement in one of the different requirements, and you'll see them on this slide. So for example, supply chain circularity. A little bit as far as percentages and tracking is concerned. If your product contains more than 10% recycled content and you have the documentation to show where that material came from, that would be valued as 1 product. If you have a company that is certified for zero waste manufacturing, which means you're diverting 90% or more of waste from landfill and or incineration, that would be valued at 1 product as well. And then if you have a product that is certified as a closed loop product, which is absolutely incredible at that point, that means it went through an actual certification process. So again, taking a look at utilizing a third party, verify the materials were recovered and that the product was recycled back into itself or into a similar or equal value product, then that qualifies as 1.5 products. And so great news in all of this is that ASSA ABLOY and other manufacturers have claims certified by third parties. So like for ASSA ABLOY, we use an organization called Green Circle Certified. And so it's important to note here that if a product is certified under that certification system with Green Circle as a closed loop product, it will qualify for 1.5 products out of the 5 permanently installed products that must be selected. So great thing to keep in mind, and a great example of how we're seeing the industry continuing to progress. Another very large market driver that we see is the architectural and design community. And of course, as individuals in the world of sustainability, we work incredibly close with the A&D community. Many of you listening in today are part of this community, and you may be looking for this type of information. So you'll see on the screen, these are just a couple of snippets of some of the firms that we're probably more familiar with hearing from. Gensler, HOK, Perkins & Will, and HDR all have sustainability commitments, as do many other firms across the country and the world. Well, what we're seeing is many more architects and designers are not only putting these types of commitments together, but being much more forward about asking for this type of product transparency information. So one of the things that we're doing at ASSA ABLOY is we're putting together our environmental product declarations and other transparency documents, like maybe health product declarations, declare labels, multi-attribute labels, to meet these types of commitments that we're seeing from these progressive firms. So We are also actively working on reducing or optimizing our products as well. And I'll show you some examples of that shortly. We do know that the AIA, their A&D materials pledge is a very hot topic right now. So you'll see just a little bit of a timeline. There's been a lot going on, either behind the scenes or more publicly, as far as the materials pledge coming out of AIA. And that was grounded in the LP50, the Living Product 50 letter that went out to the design community a number of years ago. And that was from a lot of manufacturers saying, hey, we're starting to do this good work that you proposed to us, and we're answering the call. And so we'd like to make sure that we're collaborating effectively with all of these firms that had asked us to make these positive changes within our products and our processes. And so to answer that call to that LP50 letter a number of years ago, there have been over 100 firms, and you'll see them all on this screen here, that have signed into the AIA materials pledge, which for those of you that either are part of this firm or a manufacturer, then you're familiar with it at this point. But if you're not, it's a commitment by all of the architects you see here to be better about selecting products that reduce impact on human health and that reduce the impacts on climate. So these are the core areas here. The materials pledge states that architects and designers select products that are not only saving energy, but also have reduced embodied carbon, which we're talking about today, and are designed to minimize impacts across a whole ecosystem, and are manufactured by companies that are practicing social health and equity. Equity is a very large topic in our world right now, but you'll see those core, those 5 core areas: human health, climate health, ecosystem health, social health and equity, all focused within a circular economy. So it all comes together quite nicely. Now, on the topic of circular economy, we're going to dig in a little bit on the life cycle assessment. Understanding embodied carbon comes from the information that we get from an environmental product declaration. We don't have an environmental product declaration unless we first performed a life cycle assessment. So in the world that we live in, we understand and appreciate at this point that we have many acronyms, but in this case, we're going to go through just a few of them. And some of them we've talked about already, like LCA and EPD. But in order to appreciate the relevancy of this type of documentation, it's helpful to understand where everything started. So, of course, first we have LCA, which is life cycle assessment. The first step of the process in developing an environmental product declaration is to conduct a life cycle assessment. LCAs are conducted per ISO 14040. We're all familiar with ISO, whether we've heard it in passing, we've seen it on a banner in our buildings. And it may all be also be tied to ISO 14044. So depending, could be either one of those. LCAs are developed based on something called a product category rule, or a PCR. And PCRs are completed in accordance with yet another ISO standard, that's 14025. And the PCR basically identifies what impacts you're going to be looking at and how you're going to assess them in terms of meeting the requirements of a certain product category. So those of you that work within a specific division of the building materials industry. So like for us, we worked to develop a product category rule for hollow metal doors. Depending on where else you work in the industry, you may have been involved in developing a PCR for the type of product category that you work on every single day. So PCRs are designed so that manufacturers are following a similar process and methodology, and that ensures that everyone is developing their LCAs and then in turn their EPDs in the same standardized manner, which is helpful when we're outputting a lot of this documentation and we're asking customers to use them as a research tool, right? So PCRs make it just a level playing field, basically, and comparing more apples to apples when we're developing everything in the same way. Once the life cycle assessment is completed per the category rule, an EPD is completed for all of you in the audience to review and look at when you're trying to understand and perform research when it comes to global warming potential, or GWP, or the embodied carbon within the product. The one thing that we need to think about is every step in the construction process creates an environmental impact. And that's why we perform a life cycle assessment, so that we understand from start to finish what that looks like. So you'll see on this slide that we're going to look at a couple of different impact categories. Traditionally, every environmental product declaration will address most of these, but global warming potential is the term that we'll use going forward in this discussion because it's the most relevant to the carbon footprint and embodied carbon that we're talking about today. So what is embodied carbon, right? We have for a very long time focused on operational carbon, which especially with LEED, we knew we had to measure the footprint of the building when it's in its operational or in use phase. And now what we're understanding and what we need to know to move forward to be more responsible is that embodied carbon, or what the emissions that comes during manufacture, transportation, and construction of building materials, is something that we need to focus on as well, and it can have a very large impact. So this is a very helpful illustration of the overall life cycle of a building. Depending on the type of role that we have within the project process, we may have a tendency to focus on one more than the other. If you're a supply chain person, your daily focus is on raw materials. If you are an engineer, you're focused more on manufacturing. If you're a building owner, then you're thinking about the product in its use phase. So everyone's going to serve a different role, but with LEED V4 and 4.1 and a focus on embodied carbon, we're getting to a point where we're saying, okay, we've got to kind of come out of our silos and say, how do we understand what the impact looks like throughout the entire life of the product? And how do we work together to make sure that we can reduce that? So one thing that we can do to help reduce embodied carbon in our products is to source raw materials from a closer location. That we can appreciate is obviously easier said than done, but it's something to take into consideration. Suppliers change all the time. And there are options across the country and the world. It's also important to use renewable energy in manufacturing processes. That helps to reduce impacts and energy used in our plants. It's also important to think about integrating recycled content, dematerialization, or just by making the product smaller, reducing the footprint of that product overall, and then also reducing the packaging. We've all gotten things sent to us online, ordering of some sort. The product is this big and the container it comes in is this big. So let's think differently about that. And then also let's think differently about how we're recycling or disposing of that packaging. That's how we kind of set the bar higher for products. And we as manufacturers, it's really helpful when we are pushed by the A&D community, for building owners, distributors, installers, to say we're working towards more stringent embodied carbon reductions, and we want to work with manufacturers that are helping us to design, in the long run, a much more sustainable and efficient and responsible building. To understand the full life cycle of a product, we will use one of our power supply products as an example. So this is our EcoPower power supply. And it's interesting to note here that when we're looking at the life cycle of a product, every product starts with extraction of raw materials, and then finishes with the eventual disposal at the end of life, or recycling, with the intention of being able to divert from landfill. So this is no matter what type of product, and it could be commercial, institutional, or consumer, this is typically the type of life cycle that we're going to be a part of. So how do we use the information from a life cycle assessment? This data is very important, and it is a great tool for architects and building owners to understand and select more sustainable products and materials. So typically when we're doing our product research, you're not going to see an LCA necessarily as the documentation, but you will be able to review that information within the environmental product declaration. So it's great as a research tool for customers, but it also allows the employees on our team within our organization to understand all of our environmental impacts, so that we can implement changes to make our products and operations more sustainable. So it is a tool for optimization on the manufacturing side as well. And the great thing about the availability of all this additional data is that we're getting smarter about how we're mining it and utilizing it. So a transparency tool that's recommended is the EC3 tool. And many of you have heard about this. It's an embodied carbon calculator, as you might have guessed. And as mentioned earlier, once the building is completed, the embodied carbon is there for the remainder of the building life. So if you look at the graph on this slide, you'll notice that the yellow represents all of the embodied carbon of all global new construction from 2020 to 2050. And as you can see, that yellow bar pretty much goes across the graph there for 30 years. And then the operational carbon starts out. So as soon as you start operating that building, you can see the blue graph starts to climb. And it takes about a good 10 to 15 years until the operational carbon starts to exceed the embodied carbon in the building. The point here is it's really important to be thinking about driving down embodied carbon when you're selecting products and materials in combination with optimizing the building to reduce operational carbon or energy during the whole life of the building. This story around embodied carbon makes a lot more sense when you see it mapped out like this. The EC3 tool pulls information from EPDs, and then it includes it within the tool so that anyone in our industry, architects and designers like yourself, can make more informed decisions. So a quick snapshot of the types of product categories that are within EC3. And of course, structural materials like steel and concrete are going to be the most prevalent right now, because they do have the biggest footprint or the biggest potential for embodied carbon. But that's not to say that we shouldn't consider all elements of the building. And so we use a tool like EC3 to get a better understanding of embodied carbon in the product. And I'll show you an example on the next slide. So in this case, we're taking a look at a handful of hollow metal doors from across the industry. not just ASA ABLOY, and then also the baseline, which was the Steel Door Institute's environmental product declaration. So this is actual data that was taken from the EC3 tool. And you can get an idea of the different types of doors and their impact. So you've got the baseline with the Steel Recycling Institute. The important thing to understand here is that just like with any other type of transparency tool, like a health product declaration or others, this is not the end all be all of your decision-making or your research. It's good information to an extent, but you're not comparing apples to apples because these doors could have a heavier or thicker construction. They may have a different type of core, depending on the guidelines of that building that are needed, or depending on maybe the efficiency or the types of standards that they're following. So be sure when you are putting products side by side that you've got them as close as far as their attributes are concerned to give you a more realistic comparison when you're taking a look at understanding the embodied carbon of that product. You just want to make sure that you're doing a fair comparison. And this is just a quick snapshot of what you might see in an environmental product declaration. So some of you that are heavily involved in LEED projects, you probably read EPDs very quickly. You know exactly what to look for, and you're familiar with the LCA table here. This is the type of data that's going into the EC3 tool. So if you are not using the EC3 tool on a regular basis, you can also get an understanding of embodied carbon from this LCA page within the environmental product declaration. So you've got a couple of options there. We'll talk just briefly about what a sustainable product actually is. We mentioned before, we talk about sustainability in many different ways, and there are many different terms. Sometimes it's eco-friendly, sometimes it's green, sometimes it's sustainable or energy efficient. Historically, when we think about a sustainable product, a lot of people think, oh, it's just something that has recycled content or the product saves energy. It's really important to take a multi-attribute approach when we're talking about what defines a sustainable product. Because the industry has become so progressive, you really need to tie a lot of attributes around that product to qualify it as sustainable. And this is a great example of what we might consider a sustainable product. And that is because it has a multi-attribute label tied to it. So the product here is certified by Green Circle to have a certified energy savings as compared to a previous generation. And as architects and designers, you'll want to look at products like this from multiple perspectives. So you'll also want to understand the information around a manufacturing impact and many of those other pieces of information that you see there. Is it low maintenance? Does it have an environmental product declaration? Has the packaging been reduced? Are we taking a look at recycled content, which still does come up? And then, of course, our favorite and the theme for today, which would be lower embodied energy and a lower carbon footprint. Sustainability by design. This is one that is tough for a lot of manufacturers and proves to be a good challenge for us. And within ASA ABLOY, we utilize a sustainability compass to help us outline the sustainability vision for individual products from the very beginning. So we take a look at raw materials, end of life reusability, recyclability, in-life energy consumption, carbon footprint, and financial cost. Understanding these impacts at the early stage of a product development process gives us a better idea of comparing sustainability implications of different designs so that the product goes to market as the most responsible product it can be. And our internal compass, sustainability compass, helps to do that. And this is what helps to make a better product. So you'll see an example there of a comparison of what two compass perspectives might look like. So on the top right is the ideal situation. So the further away from the outside edges there means the product is better. And on the lower left-hand side, this is kind of the worst case scenario. So this is an awareness tool that says, if you don't make the right choices in the early stages and manufacture these products, it's really hard to go back and redesign and try to reduce an impact later on. So this is just a great example, and you'll see many manufacturers working with tools like this to bring more responsible products to market, especially knowing what we know now about the way that we can be responsible in making reductions in raw materials, cost, footprint, water, and then of course, understanding what happens to the product when it reaches the end of its life. And this is another just quick example here of what sustainable product innovation actually looks like. So many deliberate steps, and you saw that with the compass as well. But if we can design a product to have a reduced impact in its life cycle, that is a huge step forward. And as you've seen with those much more stringent demands with LEED v4 and 4.1, this comes into play with that. Now, this is a good example. This is the EcoPower product that I had showed you earlier, but it has completed a life cycle assessment. And then it also went through the compass process. And the great thing about this example is, as it went through the process, we were able to understand that we had reduced the global warming potential from 13 kilograms of CO2 equivalent down to 2.4. So a significant reduction. So this is a really great example of how we made changes internally to a product. And then we were able to share with the architectural and design community that this product has been optimized, and we've taken what we've learned so that we can apply it to the LEED v4 option 2 credit that I talked about earlier. And it's also important for you as architects to be specifying more sustainable products. And that goes back to the AIA materials pledge. So we say, if you don't spec it, you won't get it. So this slide here highlights some of the sustainable specification language for Division 8 for doors and hardware. So you can see some of these sample specifications and some of the verbiage there, but it's around LEED, it's around third-party verifications, and it's also about going back to that manufacturer and working very closely to make sure that their products are reflective of what's required in these updated greened specifications. All right, so with that, we'll wrap it up for today. And we're going to talk about what I would recommend as your action plan. We talked a lot about LEED today. We talked a lot about embodied carbon. The important things to remember is that you want to be using EPDs and multi-attribute labels to understand product environmental impacts, especially those two that we talked about, embodied carbon and the global warming potential. You want to select products with lower environmental impacts. But again, I also want to be very clear that you want to be comparing them fairly. If you're doing product comparisons, you want to make sure that you're factoring in, what the use phase energy savings would be, because that's always important when it comes to the overall impact of the building. So think about that specific application as it pertains to the product when you're doing its comparison. I would also say there are so many, as a manufacturer, organizations that we work very closely with that are providing optimized products, and then integrating them into a sustainable design requirement and then into your specification. So we would consider incorporating a sustainable specification or sustainable language into the front end of the spec, but also into other divisions. We talk about division 1, and then making sure that we're following through and requesting those EPDs and third-party verifications of those optimized products. So make sure that we're following each step through. I think if you take this information that you've learned today, we can all do some really great things to design more sustainable future for all of us. So I thank you very much for attending today. I greatly appreciate your time and your support of sustainable building products. I'll open it up for any questions and answers, and I will leave you with my contact information. I look forward to hearing from you.